This is the part 2 on the tutorial for Dart classes. In this particular tutorial, we're going to talk on some other features of Dart. For now, in the first lesson, we will talk on static method and static variable. So you have static methods which you can access without creating an instance of a class. For example, you have a car with a constructor. If you know or remember, a constructor is called first when the instance of the class is created. So when a new instance of this class is created, it will print out new car created. But what if I didn't want to create an instance of a car, but I wanted to get the car price based on some values? Now I'll use the static method by appending first the word static. Now static is a keyword, so I say static void get car price. And I want to get the price based on the seat number, so I'm passing the seat number as a variable. So now we'll get the seat number and multiply it times 200, which will give us our car price. Now to do this, I didn't really need to create a whole instance of the class, so I could use a static method. Hence, that is why I did this. You could use static methods for different things. I just used this to show you an example. So let's go over to our main method and say your car. If we create a new instance of the class, what we get is that we get the printed value new car created. So if you run this, you have new car created. But let's say I didn't really want to create a new instance of the car. What I could say is car dot get car price. So notice that I use the dot operator to access the static method. So I say it has 4 seats. And using the logic, 4 times 200 is $800. So in our next lesson, we're going to talk on using the extends keyword. Now, when you extend the class, you inherit the functionality of that class. But let's use a simple example. Let's have a class called human. And you have some traits of human beings. Firstly, a human being is born. Yeah, you have a birthday, don't you? Do you? I hope you do. So first you have a birthday, you initialize the person's birthday. So I have a local variable I called age, and the year of birth is passed in from the constructor once the class is initialized. Now I will have some other methods which are some characteristics. I will just put that as human characteristics. So a human being can eat. So once I call the method eat, I should print eating. A human being can also move. You can move from one place to another. And once I call that method, I should print moving. A human being can sleep. I hope you've slept. A human being can sleep. Now, these are the qualities or some characteristics of human beings. So now, once a human being is created, I'll print out new human. So we can test this class. Let's call our human being John. Yeah, it's popular. And we'll pass in the year of birth. Remember to import the human.dat class. So we pass in a date, I'll call it 1990. He has been around for some while. So when you run this program, it should tell us new human created. Let's make that a small letter. So now after creating the human, we say John.sleep. So it creates the new human and the human is sleeping. But we haven't used the extends keyword yet. So now you can see here you have the qualities of a human. Let's add one more quality. How old is the person? So now that we have the age, perhaps if there's a function that increments the age, you can request for how old the person is. Since what we give is just the year of birth. Once we run this, it tells us 29 years old. So now let's create another class. We call this a soldier. So before we list the human qualities of a soldier, let us list what a soldier can do normally. A soldier can do what a human being can do, of course, because a soldier is a human being. But there are some differences. So we'll go on to create the constructor of our soldier class. A soldier is also born, yes, even though you might not be born with a camouflage uniform. So now we collect the year of birth also. Let's say you're registering as a soldier. You could collect your year of birth. So once we create the soldier, we write new soldier created. No, not new soldier created, new soldier. So you go down and we list some other qualities of a soldier. A soldier can shoot a gun. Of course, I know some human beings can shoot guns, but let's assume that civilians are not allowed to operate guns. So for the soldier, when he calls shoot gun, we hear boom boom. Yeah. And ambush, that is search and destroy. Now this can be done by a civilian, of course, but for the purpose of this lecture, just forget that. So now we want the soldier to have all these human qualities. What we do is we extend human. And voila, I don't need to implement all those methods. This soldier automatically has that. Now I'm going to extend the super also and input the year of birth in the constructor. What that super means is that the variable year of birth, put it in the constructor of the parent class, which is human. So here, let's create a soldier and give it a date of birth. Now, remember that the soldier does not have a method called how old, because we passed in the year of birth to the parent constructor, which is human. The human logic, that is the methods, are still part of the soldier class. So though James was born in 1995, I could still say James dot how old, even though in the soldier class there's no method called how old. So we can of course access the characteristics of the soldier. So once the year of birth has been passed and then we print new soldier, it prints new human and new soldier because it first goes to create the human, then the soldier, because we're extending the human. So the constructor of the human executes first, then the soldier. Of course, the soldier can sleep and the soldier can shoot a gun. What happens when we change this soldier to a human? Everything still works except shooting of gun. Don't shoot guns. So that's what the extend keywords can do for you to help you get the characteristics, the functionality of a class, inherit it into another class. Now, if you already know about inheritance, I'm sure you'll be very familiar with this because this is pretty straightforward. So, in the next lesson, we'll talk on abstract classes. Now, abstract classes are next. So for an abstract class, let me give an example using the design of a phone. So let's say we have a class. I'll call this mobile phone, which will have general characteristics of public phones. So an abstract class is a class that can't be instantiated. And it's useful for defining interfaces with some implementation. Some methods are not implemented. So in this abstract class, we have a method called answer call. So we just print hello. And we have make call, hi. So now a normal phone will have ability to answer call and make call. But there's a difference I want to make, which is the camera placement. Now, different phones have different camera placements. Some place it left, some place it center. Different configurations. So I'll leave this method unimplemented. That can only happen in an abstract class. If this was not an abstract class, I will get an error. So now that we have this class, we're going to use it in our phones. So we make it abstract. If it's a normal class, you have to implement all the methods. So let's create a new class which represents a phone. So which phone should we choose first? iPhone. So we have our iPhone, our first runner-up. So now this iPhone is going to we're going to use the abstract class in this iPhone. So we would not need to implement all those call and receive method. It's just the method for camera placement we will need. The next class we're going to create is Samsung. Of course, Apple and iPhone and Samsung, they're the popular guys. Of course, the other popular phones. So now, iPhone will extend the mobile phone class. And you can see the ID is crying for me to implement the method. So now I'm going to override this camera placement. Of course, those other two I don't need because they're already implemented. So camera placement for the iPhone, I will just use a notch. I just printed that. Really doesn't really have any strong meaning except for the fact that it has a notch. Then for Samsung, I'll extend the mobile phone abstract class also. And of course, it will cry for me again to implement what I have not implemented. Yes. So now what this does is that they don't need to override those other methods. That is the call and receive. But the method I left unimplemented had to be implemented by these classes. There are different use cases for this, but just know that an abstract class cannot be instantiated, and we used for this kind of examples. So let's test this in our main method. Now we create a new iPhone, my iPhone, or your iPhone, anyone. So new iPhone, and the Samsung. We also create a new Samsung. My Samsung. Yeah, my Samsung. I don't know which I prefer between my iPhone and my Samsung. So we can say my iPhone dot answer call, and when we print it, it says hello. We could also do the same for my Samsung and answer a call. We say hello. But by the time we use camera placement, the camera placement for iPhone uses a notch, and camera placement for Samsung notchless. So of course you can see the use of this in helping you design programs. So this is abstract class for the Dart programming language. Of course, you can still override the other methods in the abstract class. Let's say you wanted to customize make call for iPhone. You could still go ahead and override make call. So I'll go to iPhone and override make call. So once I override make call, I can make it and customize it to whatever I desire. So I can say iPhone is calling. So here we have overridden the make call. So it's your choice if you want to override the other methods, but you will need to implement the methods that need to be implemented. In our situation, camera placement was mandatory. It was mandatory to implement it. The others are your choice in case you want customization and the likes. So that is it for abstract classes. Our next tutorial is going to be on implicit interfaces. Implicit what? Implicit interfaces. So now the way that is, every class implicitly defines an interface containing all the instance members of the class. So in case that was too much to understand, let's use an example. So let's use an example, a sports car. Now, what can a sports car do and what does it have? So I'll list some that I think just for this tutorial. So of course you can start the engine of a sports car, and I'll print engine started once the engine is started. Let's use a car that uses button to start. Then next I'll say transmission type. So a car can either be automatic or manual, or even semi-automatic. So what this means is that there is no one type of transmission for a car. So for the car, I chose manual. Then you have the brake type. Of course, there are also different types of brakes, but I just chose a random name and wrote type A. Please, this is just for the tutorial. So now we have start engine, transmission type, brake type. Now we have fuel tank size. What is the size of the fuel tank? Of course, all cars don't have the same fuel tank size. So for this sport car, it has a big fuel tank size. Now, next, we have all these characteristics. We could actually implement the class sports car. Now, I didn't say extend, but actually implement. Because as we have those methods in sports car, it has its implicit interface. So now, let's call sports car normally as if we're just instantiating and using the methods. As you can see, I called start engine and it started the engine with a button. So now let's go on to create another class. We would call this class sport bike. Now, this is what I need to put out. A sports bike is actually similar to a sports car. Of course, there are differences and there are different characteristics, but they have similarities. A sports bike can start its engine, it has transmission type, brake type, and fuel tank size. So what I can do here is implement sport car. I didn't extend it. Now, if I extended sport car, what will happen is that sport bike will inherit the functionalities of sport car, but rather I'm implementing the sport car. So I'm just getting the blueprint of the sport car and I can determine my own implementation. This will help in having a certain structure as you're writing code instead of trying to have different designs. But you can really do a lot with this implicit interfaces. So we can also implement our brake type, fuel tank size, start engine, write our own custom implementation. So I can say type B. Of course, I'm just making this up. And fuel tank size, of course, I'll just say small, of course. Then start engine, we start the engine of the bike. Then you have transmission type. All these are now custom implemented for the bike. So once we call the bike in the main method, it calls its own implementation. But this particular sports bike class is following the design of the sports car. So this is a nice Dart feature. So of course, let's name this to sport bike and rename this to sport bike. So name this to the actual variable. So yeah, that's it. It has the same functionality by implementing sports car. So this is a real nice feature by Dart. Our sport car can still start its engine and our sport bike can start its engine. And of course, they will both start the engine and print out the results once you run the program. So our next tutorial is going to be on overriding operators. It's really interesting. Now, you have some operators like equal to, greater than, less than. You could override it for some particular cases, use cases where you wanted to compare, let's say you wanted to compare some classes. So for example, let's have a class called car. The car has a price, it has a color, and it has fuel efficiency. So let's say that you want to have a way of comparing cars to know which car is more valuable than another car, right? You would want some way to do that. So now it has this constructor which I'll use to initialize the variables. Hope you remember constructors and how to use it. So once you initialize your variables, let's now override the greater than operator. So I want to use it in such a way that I will say, if this car is greater than that car, then I should buy this car. So we just added the variable name. So this is how you define your custom operator. So now, if I have an operator greater than, I pass in the second car that I want to compare this car with. In between the brackets, I determine what would make this car better than the second car. So now, if this is what I'm going to use. If the speed of this car is greater than the speed of the second car, also, if the price of this car is less than the price of the second car, then this car is obviously better. So if this car is faster and cheaper, then it's better. I think you understand that. So we can go on and compare two cars that have different attributes and use this to compare them. Once you do that, it will print out which car is better. So in summary, if one of the cars has a higher speed and less price, a lower price, then that car will be deemed to be better. As you can see, this can be used for different things. It can be used for different things, not just the greater than sign. You can use a multiplication sign, addition sign. You can even do subtraction. So you can really do cool stuff with this. Now, if probably the first car is not the better one, it prints out the better car might be the second one. So let's create two cars. Let's import the card or dart. And we create two cars. The first is a Lamborghini. Hope you know what a Lamborghini is, Quite a fast car. So now we give it a name, price, color, fuel efficiency, and speed. So I'll name it Lambo. So we give it a price, we give it 2000. We won't say the currency yet. We give it a color blue, and yep, the fuel efficiency is great, and a speed of 380. So next we'll have, should we say Ferrari? Which car should we compare with Lamborghini? Well, let's say BMW. And the price is going to be 1,200. Wait, let's make the Lamborghini yellow because I hardly see blue Lamborghinis. The BMW will make it black. Fuel efficiency of the BMW, we can give it any just call it best. and the speed of the BMW should be around 2 something, 250. So there we have it. So now we go down and we can compare the vehicles, and to give us the analysis, we can say Lamborghini greater than BMW, and that's all we need. It's going to give us the printout. The better car might be BMW. Why did you say that? Because BMW is actually cheaper, way cheaper than the Lamborghini. And we're looking for cheapness and speed, but priority of cheapness. So perhaps imagine if the BMW was 3,200 and it still had the same speed, while the Lamborghini was 2,000 but had greater speed. The better car would be the Lambo. You get it? So this is just a very short example. You can use other operators here. It mustn't be greater than. You can use as you wish. But the thing is that as programming is, it's like clay. You can think and have your imaginations run wild. Think of what you can do with this. You can do a lot of cool stuff with it. So that would be that for that classes. And I'll see you in the next lesson. We'll be rounding up this series very soon.